Welcome back, ladies and gentlemen. In this full, we are opening up a new section known as proportionality theorems. The goal will be to use the triangle proportionality theorem to find missing side lengths. In this video specifically, we are going to define what the triangle proportionality theorem is, as well as its converse, and we're going to use said theorem to find missing side lengths. So let's dive into the triangle proportionality theorem first and foremost. The triangle proportionality theorem states that if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally to one another. Oh goodness, what does that actually break down to? Well, that tells us that, hey, if TU is parallel to QS, then it divides the triangle RQS in such a way that RT is to TQ just as RU is to US. And so if you have some colors and you're following around with your notes or anything, I try to like to make these a little bit color-coded here. If I can get colors going, RT is to TQ, and let me change colors, just as RU is to US. So pink is to pink as blue is to blue. But what's great about this as well is that the converse for this theorem also holds true. So if you say, for instance, that, hey, if you already identify that RT is to TQ just as RU is to US, then you can make the statement that TU is to QS. So we use the original proportionality theorem to show something about the proportions or the ratios of the sides, and then we use the converse to prove that based on the ratios that these two lines are parallel. Let's take a look at this in some application. So first and foremost, it says in the diagram, the following two lines, QS and UT, are parallel to one another. It gives us that RS equals 4, ST is 6, and QU is 9. What is the length of RQ? Well, let's use our triangle proportionality theorem in some application. Since QS is parallel to UT, I know right off the bat, and again, I'm going to use some colors here. I know that QR is to UQ just as RS is to ST. So I could say that RQ, we'll call it X. X is to 9 just as X is to 9. We can draw an X. X is to 9 just as 4 is to 6. So now at this point, of course, I can simplify here if I want. I can just cross multiply, but let's go ahead and just simplify just for the fun of it. 2 goes into 4 twice and into 6 3 times. Now we cross multiply. I get 3x equals 18. And of course, after dividing, x equals 6. The value of RQ actually has a value of 6. And that's how we can use our triangle proportionality theorem in some application.